Autonomous operation is a key vision for 6G networks, where complex multi-vendor RAN environments must continuously adapt to evolving requirements. However, ensuring security compliance with 3GPP and O-RAN standards remains a challenging and largely manual process. In our recent research, titled Agentic AI for 6G, a new paradigm for autonomous RAN security compliance, we developed an Agentic AI framework, where Agentic AI is deployed within the Service Management and Orchestration (SMO) layer, enabling centralized non-real-time compliance control across the RAN. The Agentic AI workflow integrates multiple components, including a compliance assessment agent, a reflection agent, a RAG-based query generator, and a knowledge and reasoning base that encodes telecommunication standards. In this video, we demonstrate how the developed framework assesses whether a central unit configuration file complies with 3GPP and O-RAN specifications. First, we upload the configuration file together with its details. We also set the service management function policies for integrity and confidentiality. Each policy can be set to either required or optional. Next, we move to the workflow implemented in N8N. The system is continuously listening for a configuration file to be uploaded for assessment. As soon as the file is uploaded, the next step prepares the inputs for the compliance assessment agent. The compliance assessment agent receives these inputs and begins its analysis. As part of this process, it calls the RAG query generator tool. This is a sub-agent that creates effective queries for retrieving relevant external knowledge. These queries are then returned to the compliance assessment agent. Using them, the agent searches the knowledge base and retrieves several relevant chunks of information. The retrieved chunks are then re-ranked, so the most useful evidence is kept and unnecessary information is removed. Next, the compliance assessment agent reasons over the retrieved evidence to identify potential violations and propose fixes. Once it determines whether the configuration is compliant, it sends its decision, together with the proposed fixes and supporting evidence, to the reflection agent. The reflection agent then evaluates whether the proposed fixes are correct. It also checks whether any violations were missed or whether any new issues were introduced in the revised configuration file. If additional issues are found, another revision round begins. If no further revisions are needed, or if the maximum number of revisions is reached, the workflow ends and the final results are displayed on the dashboard. Now we can see the dashboard. At the top, together with the file details, we can see the total number of violations identified by the compliance assessment agent, as well as the reflection agent's decision. In the next section, we see the compliance assessment summary. It states that the configuration file is non-compliant because it uses null ciphering and null integrity algorithms, even though confidentiality and integrity are required by the SMF policy. It also identifies that DRB integrity protection is disabled. For each violation, the dashboard shows the non-compliant value, the recommended fix, and the relevant standard reference. It also includes specification evidence, which summarizes the clauses used in the assessment. We can also see the reflection agent's analysis. It confirms that the compliance assessment agent correctly addressed the identified violations, introduced no new issues, and did not miss any existing ones. Finally, the dashboard provides a side-by-side comparison of the original configuration file and the proposed corrected version. In the original file, the lines identified as violations are highlighted in red. In the corrected configuration file, the corresponding fixed lines are highlighted in green. Results from this research show that Agentic RAG significantly improves compliance accuracy compared to standard RAG and no retrieval baselines, highlighting the importance of agent-driven retrieval for reliable standards reasoning.